Hello everyone, myself Sindhya Nirmastri from CS third year. So as a part of my machine learning and techniques laboratory, I have implemented the experiment number 9, which is association rule learning using a priori algorithm, where the main aim of the experiment is for the given dataset we have to generate an association rules using a priori algorithm with the support of threshold of 8% and confidence threshold of 50%. Whereas looking at the implementation from the very scratch to generate the a priori rules, the main goal is to find the frequent item sets using minimum support of 8% as given, and to generate the association rules, and also to filter the rules using the minimum confidence interval of 50%. Here we are not going to use any predefined libraries or scikit-learn libraries, where the main aim is to understand the question and generate the rules accordingly to manually understand how well the algorithm works step by step. So first, before looking into this experiment, let us understand the problem with the real world examples. So when we go to a supermarket and imagine customers buying things where, for example, milk and bread together, so then we can perform a rule like if a person buys milk, then he'll definitely buy bread. So taking this into consideration, this helps in business decisions like a product placement and recommendation in marketing. So looking into the a priori algorithm now is based on simple principle. If an item itself is frequent, then all its subset must also be frequent. So just how bread and milk are just compared and mapped together, this is how called a priori property and a priori algorithm working. So how algorithm works step by step, where first we have to generate the C1, which is nothing but candidate 1 item set, and then filter to get the L1 frequent item set. So whenever candidate buys an list of items, and then we have to figure out and find the frequent of items that a candidate have bought from the candidate item set. Next we are going to generate, in the same way we are going to generate the C2 item set mapping with the L1. Next, to get the L2, we'll filter it from the C2 item set. So we'll continue this process, and this process is called generate and prune, which will be looked into the experiment. Now, looking at the experiment and the code working, first we are going to import the data set, and transition will be empty set where we are going to append the values later, and at each item the transition in the transition list the item will be stored using append function. So the first 5 have been stored where at the transition 1 the person buys burgers, meatballs and eggs. So here we can see the list of transactions that I've made for the each person, and it have been mapped. Now we are going to display the candidate set and frequency set of for every iteration. So looking at this code, first when we look at the output, so here we see 24, where whole set whole wheat pasta french fries and low fat sugar. Next at 18 and 8 and 12, here we see a herb, pepper, tomato. So at each, after this iteration 1 is done by importing the libraries from iter tools, importing combinations. We have given a threshold of 0.08 from as from the question. So first we are going, this is the function to calculate the support. The main support is 0.8, which is nothing but 0.08, which is 8% of threshold. So for transition we have set the count to 0. At each iteration it counts. If the definite element or definite property in the list has repeated, it increases the count, and then it checks in the subset list and then add it into the transition function. This gets all the unique elements. So set function is used to get all the unique elements from the set, which has a property to remove the duplicate elements. So that set function is used. Next, here we are going to initialize the candidate set of C1, and then again we are going to iterate to find the after the iterations. And then next, for item in set of CK, which is nothing but the candidate set C1, we are going to check the frequency list to get the L2, as we have checked in the algorithm before. So at each generation, I in the range of length of ck, which is nothing but the lk, which is going to be generated, and j in the range. So this will be the another transition function which we will be iterating through to check for the subset of elements that have been present. So if the element is present, that is stored in the list. So if it look at the 24 number of 24, the support it is 0.04, and the whole wheat, pasta, and french fries. So every new number is mapped to the new unit number, as you can see here. So this is how the working of the candidate set and frequency at each frequency repetition works. Next, we are going to display the association rules for this accordingly. So when we check here, the 1 is associated to burgers, meatballs, and eggs, whereas the 2 is associated to mineral, water, milk, energy bar, wholesale. So looking into it, how we have done it. So first in transition set, looking into the transitions, we will be iterating over the loop to check each and every element. So the number which is mapped to the definite element will be printed here. So looking at to the 1, numbering as it a 1, burgers, meatballs, and eggs are mapped to the only one. So whenever customer buys burger, he'll buy meatballs and eggs. And this is how we have figured out the transition rules by iterating throughout the function of this. Next, for calculating the support list, we are getting the method by using get support method after the transition from here, and then we'll get the support, which is the threshold of 8% to the greater than 8% and less than 50% of threshold. So once after the rule, we have printed all this accordingly. So as you can see, so yeah, this is the end of the experiment, where it concludes that each and every step where we have look into is first we are going to generate the candidate item set, and the next, which is C1, and from the candidate item set we are going to generate L1, which is the frequent item list bought by the person from the candidate C1 list. And then from later on we are going to use L1 to generate the C2 accordingly and pairing up. So later we are going to generate and filter the L2 accordingly, which would help us in mapping the associated rules by the process of generate and print. So concluding this video, in this experiment we have implemented the Apriori algorithm step by step, where we generated the candidate set, filtered the frequent item list using support threshold, which is 0.08 and 80%, and created association rules using the confidence interval as 50% as given from the question. So this experiment helps us understand how real world recommendation system works, and we have implemented the whole thing using human readable code, but not using any machine learning libraries. Thank you.